Hey folks, this is Dr. Emily Scherning with American Resiliency. It's time for another international outlook. In this video, we'll look at projected changes to South Asia, encompassing the nations of Pakistan, India, and Bangladesh. This is one of the most densely populated regions in the world. There are about 8 billion people alive today, right? And close to a quarter of humanity lives in this region, lives in South Asia. This region, it has a distinct water cycle. Life there, it relies on the monsoon, a regular, dramatic seasonal shift in the wind between the warm sea and the Indian Ocean and the cold mountain heights. When the wind shifts inland, it brings rain. Most of the region's freshwater comes with the monsoon. There's also factors with glaciers that we'll talk about later in this video. But the monsoon is important as we look at a warming world. There have been long-standing and serious concerns that we might see changes to the monsoon as we cross the 1.5°C warming threshold above pre-industrial baseline conditions. Unusual wind and precipitation behavior was observed in the summer of 25, where we saw the monsoon cross the Himalayas into Tibet for the first time. There will be a link in the video description if you want to read more about this event. When we are looking at this region of the world, I think it's an important baseline to understand that there's a very important tipping point potentially in play. If the regularity of the monsoon should fail, words fail to describe the suffering that would unfold. The region would experience rapid landscape change, ecological devastation, and profound direct impacts to not just millions, but billions of human beings. So, as we're looking towards this crucial, culturally rich cradle of human civilization, that's the baseline, is that we know this is a sensitive tipping point region. And I think that that's the most important information that needs to underlie the rest of the modeling we're going to look at now. I'm going to be visualizing other factors here with AMOCscenarios.org. This is a wonderful, fairly new global modeling tool. It's available to the public. It does go down sometimes if it gets heavy traffic. So if you get on there and it's not working, try it again. In terms of temperature, it's interesting. So right now, I've got the pre-industrial baseline visualized. Right now, the factor that I'm looking at is pre-industrial climate, June, July, August temperature. So your average hot season temperature. And when we look out to a 2C scenario, which many are now projecting could occur by the mid-2030s, if we look at it with AMOC on, a standard warming scenario, or if we look with collapsed AMOC, you can see fairly little difference in the color. The average temperatures change fairly little, regardless of the tipping point scenario at 2C throughout South Asia. If the average heat in the summer here, the average isn't the real story. What people are experiencing in this part of the world that is concerning, it's not the average heat, it's the heat waves. Major heat waves are a concern. They're becoming longer, more common, and they have higher peaks. It's already killing people. A deadly heat wave in Karachi killed 1,300 people at least back in 2015. We can see in this reporting from the BBC. Karachi is not a city where extreme heat is unusual. We're moving towards heat waves of an overwhelming intensity where major cities in South Asia could experience frequent summer mass casualty events. The heat extremes, big heat wave peaks, let's check out how they're going to change in these scenarios. Looking at warm extreme events, we can see that throughout South Asia, we're used to pretty big extreme events, approaching 50°C heat waves. In a standard warming scenario, we see those intensify substantially, likely to go above 50°C. We see some of the most intense warming for these extreme events for heat waves over towards Pakistan, over 52°C. In the event of AMOC collapse, in the event that we do see big phase change in heat transport in the world's ocean, we're still projecting heat wave peaks over 50°C You can see there I've got a pin towards the coast near Pakistan, as well as that earlier one over in Bangladesh, throughout India as well, under both scenarios, collapsed AMOC or not collapsed AMOC, tipping point or not. Heat wave peaks exceeding 50C, in some cases by a very uncomfortably large margin. For our American audience, it's worth noting 50C means heat waves over 120, often in humid climates we're talking about in South Asia. That's terrible heat. I've only experienced that once in my life, and I hope I won't again. Experiencing that level of heat in humid conditions could easily prove fatal to even healthy young adults, especially in scenarios where the heat is prolonged and the temperature doesn't drop meaningfully at night. When we're talking about the extreme heat that's projected to come to South Asia, not only as it's coming now at 1.5, but as we continue to warm, as we move towards 2, we're talking about not just changes in those peaks, we're talking about reduced nighttime cooling as well, which will reduce everyone's ability to recover from the daytime heat. And we're talking about them becoming longer. All of those factors together increase the public health impacts of these extreme heat waves. In some parts of the world, it makes sense to look at whether the tipping point scenario improves local outcomes or not. The modest drop in heat wave peak that we might expect with the tipping point scenario is no counterweight to the dreadful possibility of monsoon shift when we consider outcomes for South Asia. For this region, the tipping point scenario is substantially more dangerous than a standard warming scenario. Overall, we see South Asia heating by about a degree or 2C in the summer average in either warming scenario, with very dangerous heat waves emerging in either scenario. Now we're back in the visualization to look at winter change. In the winter season, the average winter temperature will increase slightly in a standard warming pathway. Let's check that out. Here we're looking at the pre-industrial climate, standard warming with AMOC on. You can see that there's like a degree C shift across most of South Asia. If we see that tipping point hit, if we see those changes in the world's oceans, which will impact global weather patterns, we see reduced change, still a little warmer in the winter, but not as much. And that's true across the region. I also checked out cold extreme events for South Asia, big winter cold snaps. To zoom out a little bit, because here we're looking at cold extreme events for much of the world on the map here in the pre-industrial climate. With collapsed AMOC, we see an increase in cold extreme events move down and really impact Northern Europe. Here's the AMOC on the standard warming scenario. Check out this area, visualize this area. Dramatic change with collapsed AMOC. I was wondering if there would be substantial winter change for South Asia between these scenarios. There's really not. In Pakistan, we find a few places where cold extreme events would bring temperatures below 0C, but by and large, the cold snaps are not a significant impact. They're not likely to kill plants, cause major landscape change. On this factor, on winter temperature, South Asia is honestly looking quite calm in terms of winter change across models. And this was a surprise to me. And it's an important positive. It's a strength for the region. The lack of severe winter change will help stabilize the health of mature plants and ecosystems throughout the region. And looking at average temperatures changing relatively little, those big heat waves are a concern, but we're not talking about a huge shift in summer averages. We're not talking about a huge shift in winter averages. We're looking at a typically tropical outcome in terms of the averages, and that's a comfort for the region. The changes we're seeing projected for this part of the world on average are fairly small. However, those extreme events, the extreme summer heat events, are potential killers. There's no minimizing that. And temperature stability, we have to hold on to the fact that that doesn't necessarily translate into water cycle stability. Precipitation is the real concern for South Asia, and let's see what we know about those trends. There have been observed changes in the intensity of rain across South Asia in the last 5 years. A destructive pattern of drought and deluge, which is expected to occur in most parts of our warming world, has become evident. Deadly droughts and floods are increasing in observed and experienced severity across this broad, densely populated region as we do begin to see the monsoon become more erratic. Wet years have become wetter and dry years have become drier. The impact on small farms, and many people support themselves through family-level agriculture, subsistence-level agriculture across this broad and diverse region. It's already been devastating. I want to share some contemporary reporting regarding the impacts of both drought and flood in Pakistan. In 2022, 8 million people were displaced in Pakistan alone by flooding, and in 2025, another 2 billion. More than 2,000 villages have been destroyed in Pakistan in the last few years. Entire communities are being displaced due to these catastrophic floods now. It is not a future problem. South Asia was projected to experience very painful change at 1.5 C. This is not a tomorrow problem for South Asia. It's a serious problem now, and it's likely to intensify. Looking east to Bangladesh, I'd like to remind us, and many may not have heard of this, as the quality of global reporting is in decline. It is worth noting the 2024 floods that impacted much of South Asia. Bangladesh had flash floods that trapped more than 1.2 million families because the water rose so fast. In either a standard warming scenario or a tipping point scenario, we expect these drought and deluge patterns to intensify. In the tipping point scenario, we expect even more extreme shifts to occur, with an overall drought trend in the western part of South Asia falling most heavily over Pakistan, and an overall deluge trend emerging to the east of South Asia, falling most heavily over Bangladesh. Seeing that kind of differential emerge within the monsoon rains year over year would be another form of observable evidence that would suggest we are experiencing phase change in ocean heat transport, which is expected to change precipitation patterns in many parts of the world. Monsoon is not the only major water system that is changing in this region. We are also currently observing changes to the glaciers of the Himalayas. Because of a lack of satellite imaging, much of the observations that can be done to verify the changes in the glaciers are from comparing historical photographs to today. We see massive retreat in many glaciers. We are seeing lakes forming high in the mountains that were not there before. The glaciers of the Himalayas are a major source of fresh water. Their seasonal melt contributes to the flow of the Ganges, the Indus, the Mekong, and the Yellow rivers. So we're talking about the heart of Asia's hydrology. The seasonal melt of those glaciers is part of an ancient rhythm, but now they're melting much faster than they can be replenished. That doesn't create only a long-term serious concern for many of Asia's great rivers, that also increases the risk of a particular natural disaster, the GLOF. That stands for Glacial Lake Outburst Flood. I needed a picture to help me understand that phenomena. I wasn't familiar with the term GLOF when I was putting the script for this video together. This is one of the best pictures I could find. You can see how if you've got a glacial lake melting down from the glacier, anytime that there's a big disturbance, like a landslide, an avalanche, you could get a breach in the boundary of the lake. The lake's going to overflow. You get massive flooding down below. It's kind of like you can get a lake thrown at you down the mountain. That's the sort of disaster that can cause massive damage and massive loss of life. There's very little warning when those strikes, and the force of the water is enormous. Well, this risk, the GLOF risk, isn't present in as much of the region as that dangerous drought deluge pattern, we're still talking about a pretty broad risk. Imagine a whole lake gets dumped into a river and you live within a few hundred miles downstream. Flood risk is a risk that carries. To understand more about this risk, we've got a peer-reviewed research article showing that flood hazard under current and future conditions for people who want to dig further into this topic, a great resource in the video description. As we're exploring water risks, it's time to take a minute and look at sea level rise. I'm visualizing that on coastal.climatecentral.org. That's another great publicly available global modeling tool. I'm modeling here a meter of sea level rise, which is higher than some would consider for 2C, because this is going to happen slow at first, but we're likely to see higher sea level rise than a meter by the end of the century. There are concerning rapid meltwater trends being observed at both poles. When we consider also coastal storms that can drive storm surge, it seems very reasonable to me to consider a meter of sea level rise as a good way to assess baseline vulnerability in this region. This tool you'll see in a bit, you can zoom down to street level view and check out what's projected right where you live with this high quality validated tool. From even this big picture view, this very far up, like from space view, we can see that Pakistan and Bangladesh both have some quite vulnerable coastline. In Pakistan, we see some inundation projected for Karachi. Let's zoom in there. You may recall we talked about that deadly heat wave, the 2015 deadly heat wave in Karachi earlier. So seeing these compounding threats, that's always very sad. We can see some impacts beginning to hit the built environment at 1 meter, but that these smaller nearby communities and the wildlife sanctuary are looking at inundation by a meter of sea level rise. That's sadly a very common situation, that small communities and wildlife sanctuaries suffer the most and they don't receive much attention. Because you'll see, let's move east, let's go look more at India. I think you'll see why as we start to move into India and we look at Mumbai, enormous city, extremely developed area. We can see substantial urban impact, substantial impact to the built environment in Mumbai. Here, we're zooming in a little bit so that you can see the level of street level visualization. Things looking bad for the race course. This is a lot of people looking at direct impacts in Mumbai. I'm coming down and looking at Kochi for a minute. We got a major port city, major port area here, millions of people living in this area where we see direct inundation at 1 meter. These are very severe impacts for our American audience. You'll note that these are worse impacts than we project for any major U.S. coastal city at a meter of sea level rise. The number of people who will be impacted directly by sea level rise throughout South Asia is an order of magnitude greater than in the U.S. Also, from a global perspective, when we see these projected impacts around major ports, it's important to think about the rippling impacts to infrastructure and global logistics. Fortunately, not all Indian coastal cities are looking at this same level of risk. Let's go check a brighter spot. Let's go look at Puducherry. You can see this city looks quite strong, resilient against sea level rise. There's 1 million people in this metro alone. I popped up next to Chennai, the much larger city, 6.6 million in the metro area itself, also looking fairly strong. So when you're looking at major cities on India's western versus eastern coast, I hope you can see there's very differential impacts projected for sea level rise. That does change as we move up towards Bangladesh. It is towards Bangladesh that we will see the most catastrophic impacts in the region of sea level rise. We can see that for Kolkata in India and Khulna in Bangladesh, these are catastrophic impacts. We're looking at complete inundation of substantial built environment where many people live, millions and millions of people live. Of these many millions of impacted people, there is in this part of the world a great poverty and inequality. You can see that at a meter of sea level rise, Kelowna's land area is mostly gone. And more than a meter of sea level rise might well emerge before the end of this calamitous century. When I became aware of the climate projections for Bangladesh many years ago, it struck me as so cruel that the widely promoted symbol for climate change in the US is the polar bear. To me, that shows such a great lack of compassion. I mean, shouldn't the symbol we hold up be the children of Bangladesh? What's wrong with us that anyone should imagine more personal identification, more of a response related to a large white bear that actively wants to eat you than a Bengali girl, than a Bengali child? I had the great privilege of working in the lab in my youth with a woman from Bangladesh. She had emigrated to America, earned a PhD, a brilliant, dedicated scholar. She told me about her childhood in Kelowna, how in the rainy season she once watched a girl her age be washed into a storm drain and nobody did anything. Everyone just kept about their business. The car that she was in continued on. And as she cried, her father told her this was why she should emigrate. I remain grateful that she told me this story because I see this world with American eyes. Everyone has limits to their vision, brings assumptions they're not aware of, things that they don't consider. Looking with American eyes at the problems facing South Asia, there's a lot we don't see. There's a lot of response capacity we assume that does not speak to the lived experience of many people in these areas that are at such risk. When we see these projections for sea level rise, for killing 50 C plus heat waves, I think we need to look at the work being done in this region, even in the last 10 years, to lift people out of poverty. In this region, there's a need for broad investment. The world's poor are not the people who have gotten us into this situation. They're not the people who have reaped the benefits, and they are the people who are going to pay the price for the way we have treated our world. We are at 1.5 C. The 1.5 C impacts to South Asia are unfolding as expected. They are severe. The heat waves, the drought and deluge, they are only beginning. They are projected to continue to intensify. I speak with many Americans who are very concerned about the impacts of climate change in America. For those Americans watching, I hope you will see we are not first in the triage line here. There are no outcomes in the US as severe as the impacts to South Asia. For people across South Asia, resilience will mean water, storing water, channeling water, helping water to move across the landscape when there is too much, finding ways to store water for dry years. People are already struggling on this account. Wells are going dry in large parts of Pakistan, in large parts of India. I would like to highlight this organization, the Safe Water Network, as just one example of action on the ground, here in this case in India, that helps solve last mile water problems, that helps get water to people. Access to clean, safe water should be a human right. When we look to the future of South Asia, we must recognize the work that people are already doing around water and consider that work in an additional light as a profoundly critical response to climate change, as pivotal resilience work. An AR community member, Taco Baco, also shared this story, remembering their experiences in this part of the world, where the peril and the action, the hope on the ground, the impact of people on the ground, including heroic figures like Dr. Rajendra Singh here, including communities working to revive traditional water resilience measures like johads, including everyone who is not fighting to win, but who is fighting to do the best they can in this narrow frame in which we find ourselves. It all makes me move emotionally beyond the flavors of hope and despair we have associated with climate in the past. There was a time when the narrative promoted was, we can stop this, we can turn this back. Then that was what hope meant, was that we could turn this back, and despair meant perhaps we could not. We live in a harder world now. We have crossed the 1.5 C threshold. Hope, to me, in this time, it means to save what we can save, to build the best future we can in these times of change. This grim hope, this courageous hope, is a hope that deserves to be recognized on the ground, and it shines out of South Asia. This report that I've given you here, this is the experience a quarter of humanity will face in our warming world. We are facing complex, disastrous global impacts. They are unfurling as expected as we live here now at 1.5 C. For those of us looking at lower change outlooks with fewer direct hazards to life, it matters to save what we can save, to save what life we can save. The outcomes we are facing are not fair. They are not just. If you're a person who has the power and capacity to act, our action on the ground matters. Wherever islands of stability might emerge, it is better they should emerge. I hope this information has been useful to you. To my American audience, I hope this has given you some important perspective on global risks and hazards. And I'll look forward to talking with you all again soon. And I want to say, if you've been thinking about donating to AR, please consider giving before the end of the year. We are rolling out new login-only web features next year that will be free to all current donors and regular volunteers, but we need you to get into our records by the end of 2025 to receive that benefit. Any pledge is appreciated. And if your employer offers donation matching, please note AR is an eligible 501c3 organization. Next year, I'm going to bet that life will continue to be real weird and hard and probably pretty scary sometimes. I'm so grateful I'll be able to spend that year with you all because of AR.